a collaborative pair whiteboard instructional strategy. What is cosine? Cosine is a strategy that requires students to communicate and collaborate while working in pairs. The activity begins when students are given a problem to solve. One student completes a problem on a whiteboard while the other student completes a problem on a scrap piece of paper. When both have finished, the student working on the scrap paper analyzes the other student's work and cosigns his or her name on the whiteboard if they agree with the answer. If the student does not agree with the work on the board, he or she must begin asking the other students questions about the process they took to solve the problem. Questioning is used instead of directly telling a student where a perceived mistake was made to promote discussion and analysis of the content. Students are required to explain their reasoning and justify the steps they took to solve a problem. Once again, when both students come to an agreement about the solution, they sign their name, which signifies they are jointly responsible for the answer. So what's the real-life connection? Well, what do you do if a relative or friend asks you to co-sign on a loan? Before saying yes, you need to think about the obligations involved and how they may affect your own finances and credit. When you co-sign a loan, you're taking a risk the lender won't take. By co-signing, you are jointly responsible for paying back the loan, even if it is the other person who fails to make the payments. Therefore, it is important to ask questions and make sure you understand and agree with all the information before co-signing. The co-signing activity addresses several of the Common Core mathematical practices, including making sense of problems and persevering in solving them, reasoning abstractly and quantitatively, specifically the decontextualized information where you take the numbers out of context and work with them mathematically, attend to precision, especially for communicating where we can speak, read, write, and listen mathematically. And then also construct viable arguments and critique the reasoning of others. And again, we're going to look at listening, comparing arguments, identifying flawed logic, etc. So here's an example of how to use cosine. Here we start with the problem. The cab companies below each charge an initial fee plus an additional charge per mile, and we have Uber with their rates as well as Beach Taxi. And the question asks, based on the cost, when should you use Uber and when should you use Beach Taxi? So here is a student example. Here we have the student first. We're going to chunk this one a little bit. So the first thing we're going to ask them to do is set up the equations they could use to solve to find when the cost would be equal. And when I do this, I'll typically have the student's initial next to the name if they agree. So here the student agreed with the equation, and we went ahead and just initialed next to it. Next, we see an example of the student doing a little bit more work here, and they get to the answer of x equals 5. Let's say the student working on the scrap piece of paper did not agree with this. So they may ask a question like, how did you come up with 6/10 x? And they might look over their board. And again, we don't want to directly tell them that they made the mistake right here by adding. Maybe ask a question like, okay, well, when you moved the 0.2x, the 2/10 x to the other side, how is it a positive number? Why did you add 2/10 x to 4/10 x? And they might ask them something if they're still not identifying the mistake. Well, what happens when you move one term from one side to the other side? How should it look when it changes sides? Connect it to when you're driving on the road and you make a U-turn, what direction are you going when you make that U-turn? And hopefully they see that it's opposite, so that if we have a positive here, it should be a negative on this side. So the student who did the original problem maybe looks back over their work, listening to the questioning, and here they then identify their mistake and realize they should have subtracted the 2/10 x from this side. So here they've gone, and now both students agree, so we go ahead and initialize the work there. So now we know that the companies are equal at 15 miles, but the question asks them which one should they use, and well, that really depends, doesn't it? So the final part with that would be using the y-intercept and the slope. They might say that the companies have the same cost for 15 miles, but you would want to use Beach Taxi when the number of miles is less than 15 miles, and use Uber when greater than. Now that's the right answer, but we might want to follow up with a few questions. Well, how did you know Beach Taxi was better for under 15 miles? And hopefully they would say something like, well, it had a lower pickup fee and a lower initial value. And how would you know that Uber would be the better deal over 15 miles? And they might say something like, well, it has a lower rate, so even though it has a larger upfront fee, pickup fee, over time, the lower charge per mile is going to make it less expensive in the long run. And in this case, it means over 15 miles. So that's it. There's our cosine activity.